Okay, this is the notes page for solving exponential and logarithmic equations. So to start with, some exponential and log equations can be solved using properties. You may remember if you have the same base, b of the x equals b of the y, you can drop the bases and just set x equal to y. Or you may remember this property, the log base b of b to the x is simply x. So for example, 3 to the x equals 1/9. You have to kind of know that 9 is 3 squared. So you can rewrite this as 3 to the x equals 3 to the negative 2. And then now you have the same base, so x is simply equal to negative 2. So you always want to be on the lookout to see if anything can be written as the same base. Similarly, you have a base 2 and 32 might ring a bell. That's 2 to the 5th. So if you rewrite that as log base 2 of 2 to the 5th equals x, then we can use this property. And log base 2 of 2 to the 5th is 5, so x equals 5. And then kind of like this one, you have a base 2 and a base 8. Well, 8 is 2 cubed. So you can rewrite this as 2 to the x minus 4 equals 2 cubed to the x plus 5. Then exponent to exponent, you can multiply those together. So that's 2 to the x minus 4 equals 2 to the 3x plus 15. And now you have the same base, so you can drop the bases and set x minus 4 equals 3x plus 15 equal to each other. So that's going to give you 2x is equal to negative 19, and x is equal to negative 19 over 2. Okay, but let's go into something a little bit newer. General rules for solving exponential and logarithmic equations. So what happens if you have an exponential equation and 3 and 7? There's no way you can make those the same base. Alright, so you've got to know how to get x out of the spot. Our objective when we're asked to solve the equation is to find out what x is. Now you can't get the 3 away from the x, the plus 2 away from the x. It's stuck there, so we need a new method. You can't use division, can't use subtraction, so we need a new method. And so when you have an exponential equation and you can't get the same base, what you're going to do is you're going to take the natural log of both sides and then use the power property to get the x out of that exponent spot. You could take the log of both sides, but it's usually easier just to do the natural log. Okay, so this is legal. So I have the equation in the form b to the x equals y. That's important. So now I'm going to take the natural log of both sides. So I'm just going to write ln in front of both. Okay, completely legal to do that. Then what we're going to do is we're going to use the power property. Remember the power property? Power property says if you have a power, you can put it in the front as multiplication. Now when you do that, there's two terms, so this would be wrong. You'd get in trouble there. You got to use parentheses. That would be right. So we put that x plus 2 in the front times natural log of 3 equals the natural log of 7. Okay, now there's a couple of things you can do. You can distribute this natural log of 3, or you can divide it out. That's what I'm going to do. This is just a number. It's really hard for students because it's letters, but natural log of 3 is 1.098612289, and it repeats on and on and on never. So we don't want you to approximate that, but it's just a number. So this is x plus 2 times a number equals a number. So we're going to try to get x by itself, so we're going to divide by this number. That cancels and leaves me with x plus 2. And you can't divide 7 and 3. It's just natural log of 7 divided by natural log of 3. Then we can get rid of this 2 by subtracting 2. So you get x equals the natural log of 7 over the natural log of 3, all that minus 2. And the good thing about solving exponential equations is, remember, exponential functions, the domain is all real numbers. So there's never going to be a restriction on x. If you can solve it, you've got the answer. Okay, let's move to the next example. 5 to the x minus 1 equals 6 to the 2x plus 1. So there's no same base that you can get 5 and 6 to be the same. So you're going to have to use this method. We're trying to solve for x, and we want to get x out of that exponent spot. It's a two-step process. You're going to take the natural log of both sides. You're going to use the power property, and then there's more steps to this one. So, all right. So step 1, take the natural log of both sides. Okay, and I'll put the parentheses around here just so you're not confused. All right, now I'm going to use the power property. So remember, you got two terms. So when you put that power x minus 1 in the front, please make sure you put parentheses around it. It's really important. Same thing with this 2x plus 1. That's the power. That's one power. It's two terms. You need parentheses around it. All right, so step 1, take the natural log of both sides. Step 2, use the power property. Okay, now step 3 is new. The problem here is you've got an x on both sides. So we've done this before with inverses. It's a technique that you need to understand. What we have to do is get the x terms on the same side and the non-x terms on the other side. Okay, so what's next is we're going to have to distribute. And again, it's a little tricky because people kind of just don't like that this is a number. It's a number. It's a number, so I'm going to distribute it just like I would any other number, and that gives me x times natural log of 5 minus 1 times natural log of 5. And I'm going to distribute natural log of 6 to these two. So that's 2x natural log of 6 plus 1 natural log of 6. So I distributed. And now what I have 4 terms. See that? And 2 of those terms have an x in it and 2 don't. So that's the next step, is you want to get your x terms on the same side. And the way you do that, remember, when you move something over the equal sign, it changes sign. So this x natural log of 5 is on the left. That's good. This 2x natural log of 6 needs to go to the left, so it's going to become minus 2x natural log of 6. This minus 1 natural log of 5 needs to go over to positive 1 natural log of 5, and this natural log of 6 is already on the right. So I move 2 of the terms. I move this x term over here, and I move that constant term over there. All right, what's next? It's kind of what we did for inverses. Now we have 2 x terms on the same side, and they both have an x in common, and our job is to get x by itself. So let's factor out the x. So if you pull an x out of that, we're left with natural log of 5. We pull an x out of that, we're left with 2 natural log of 6. And we'll copy down the right side. So now we finally have an operation we know how to do something with. The opposite of multiplication is division. So we're going to multiply both sides by natural log of 5 minus 2 natural log of 6. They cancel, and you get x equals, and don't cancel these, that's a grouping symbol. Can't do that. This is as simple as it gets. This is what we call an exact answer. So do not pick up your calculator and give me the decimal. We want the exact answer. Alright, so now this is hard, but the steps are not going to change. Okay, so you're going to take the ln of both sides. You're going to use the power rule. Then, this is the new part, you're going to distribute. Then you're going to get your x terms on one side, I'll say on the left. And your constant terms, the ones that don't have an x, on the right. And once you've done that, you're going to factor out the x. And then once you've done that, you're going to divide. And so this is not a high-level problem. if you can not get hung up with the natural log of 5 being a number. It's the same steps every single time. So the cool thing about these is you can make them up. They're also in the lab manual because there's no domain restriction. So you can just keep practicing and practicing it. Alright, but let's move on to the next type. So this one, 8e to the 2x minus 3 equals 20, has got two things going on. The first thing is it's not in the right form. You need to just have a base to the x equals y. If you have a times b to the x equals y, your first step is always going to be to divide out that value there. Okay, so you have to do that first. So that's what's going on here. You have this 8 times e to the 2x minus 3 equals 20. So before we do anything else, we've just got to divide out that 8. We have to have just the base to a power equals a number, and 20 divided by 8, I know that's a terminating decimal, so I'm going to write it like that, 2.5, 20 divided by 8. Okay, so now here's the next thing. You're still going to do the same thing. You're going to take the natural log of both sides and use the power rule to get that exponent, that x, out of that exponent spot. Alright, this is legal. Take the natural log of both sides. Use the power rule. This is one power, but it's two terms, so please use parentheses. Okay, now we have the new thing. This is the other reason why we take the natural log instead of the log, because if you're having e here, remember the natural log of e is equal to 1 because the base is e and there's a 1. So the natural log of e is 1. So once you do these two steps, the natural log of e is gone because that's just 1. So you end up with 2x minus 3 equals natural log of 2.5. Doesn't matter how hard that is. All you're trying to do is get x by itself. So you know how to do this. You add 3 to both sides. So that's 2x is equal to natural log of 2.5 plus 3. Now this bothers me a little. I wouldn't count it wrong, but we usually like to put the integer or whatever in the front of the natural log so we don't get confused and think they're together, because they're not. So I'm going to fix it. But before I do, I'm going to go ahead and divide by 2. So x equals 3 plus natural log of 2.5, all of that over 2. That just looks a little bit better to put we don't want this 3 to fall into that function there. So that's it. Okay, so what do we learn on this one? We have to divide out the product there, the 8 first. Alright, kind of the same thing here. We need to get our equations, exponential functions in this form. Okay, so we have some work to do here. Here's the power, so this is b to the x. So I'm going to need to get rid of this 2 and this minus 3/4 times e. So you have to know how to do that. So we have to get rid of this 2 first by subtracting 2. So that's negative 7 equals a negative 3/4 e to the 2x minus 3. Now we have to know how to get rid of that negative 3/4. You can divide by negative 3/4. I personally have told you in other videos like to multiply by the reciprocal. Okay, so negative 3/4 times negative 4/3 multiplies to 1. So that gives me 28 over 3 on the left equals e to the 2x minus 3. Alright, so now we have it in the right form. B to the x equals y. So we are going to take the log of both sides, the ln of both sides, and then we're going to use the power rule to get that exponent out of that spot. And we're going to make sure that we put parentheses around it. Okay, and then ln of e is 1. Notice that I'm not putting 9.33 repeating here. That's an approximation. I want exact answers, so I'm going to leave that 28 over 3. Okay, so now I just have 2x minus 3. So I'm going to add 3 to both sides. That cancels. And then I'm going to divide by 2. So x equals 3 plus ln of 28 over 3 all over 2. So those are examples on how to solve exponential equations. To solve log equations, all right, they're a little bit different. One of the main things that I need to tell you why they're different is because, remember, if you have a log function, there is a restriction on that spot. Whatever's in that spot has to be greater than 0. So there is a domain restriction. So then, just like rational equations, you have to check your answers that you get for extraneous solutions. Okay? And there are 2 types of log equations. One, you might have logs on both sides. Every term in the problem might have a log with it. See that? That has a log, this term has a log, that term has a log, as opposed to like down here. See how that 2 does not have a log? You have to solve that a different way. Okay. So if you have logs on both sides, what we're going to do is use the properties that we learned, mainly the product property and the quotient property or rule. And rather than write them down, I'll show you what's going on here. So here, and the power rule. We'll put that down because you get to use the power rule too. Alright, so here you have 2 times log of x. Well, I can make that log of x squared using the power rule. And then here I have 2 logs added. And 2 logs added, log of 2 plus log of x plus 4 is the same as the log of 2 times x plus 4. That's the product rule there. And that's what you want to do on these problems, because now you've got 1 log on the left and 1 log on the right. So you want to use the properties to get 1 log on the left and 1 log on the right, because now once you have 1 log on the left and 1 log on the right, you can drop the logs and just set x squared equal to 2x plus 8. So you want to try to drop the logs. You can't do that unless you have 1 log on the left, and that's it, and another log on the right. So I use the power rule and I use the product rule. Instead of having 2 logs added, I wrote it as 1 log multiplied. Okay, so now you have a simple quadratic. Okay, so remember, you have to set a quadratic equal to 0 to solve that, and that factors into x minus 4 and x plus 2. So you get x equals 4 or x equals negative 2. Okay, but see, when you drop the log, this quadratic doesn't know that there's restrictions on it. So you're going to get answers that work for this quadratic, but they may not work for the original. Okay, so remember, what you have to do next with a log equation is these spots right here have to be greater than 0. So if I put 4 into this x, that's okay. If I put 4 into this x, I get 8, that's greater than 0, so this 4 is going to work just fine. But look at this negative 2. If I put negative 2 right here, that's a violation. X has to be greater than 0. So that's what we call an extraneous solution, because it came legitimately from this quadratic, but the original problem, always go back to the original, was a log. So the only answer there is x equals 4. Alright, let's try another one. We have, check everything. There's 3 terms, 1, 2, 3, and every single one of them has a log in front of it. This time it's base 3. So you're going to be able to use the properties to get 1 log on the left and 1 log on the right, so you can drop the logs. So this time we've got 2 logs subtracted. So we're going to use the quotient rule and write that as 1 log base 3 of x plus 20 divided by x equals log base 3 of x plus 8. So using the quotient property, I got 1 log on the left, 1 log on the right. So now I can drop these logs and just set x plus 20 over x equals x plus 8 over 1. Alright, now I've mentioned this a few videos back. This is when you have one fraction on the left and one fraction on the right, there's this tool technique called cross multiplication. So that's what we want to do there. That's why I put a 1 there. So I'm going to cross multiply. 1 times x plus 20 is x plus 20. And x times x plus 8 is x squared plus 8x. And there's another quadratic. So I'm going to set that equal to 0. So that's x squared. Move that x over there. That's positive 7x. Move that 20 over there. That's minus 20. So we have x squared plus 7x minus 20. Factors of 20, they do not subtract to be 7. 1 and 20, 2 and 10, 4 and 5, they sure don't. So this is kind of a rare one. We still need to try to solve it, but we can't factor it. It's not going to factor. So we'll use the quadratic formula. That can happen. So x equals negative 7 plus or minus the square root of b squared, which is 49, minus 4 times a, which is 1, times negative 20. All over 2 times 1. So x equals negative 7 plus or minus what is 49 minus 4 times 1 times negative 20, square root of 129 over 2. Alright, and that would be done, except this answer came from this quadratic, but this is not starting out as a quadratic, it's starting out as logs, and there are restrictions on logs. You can't have a negative there. So this is my potential final answer, but I'm going to take a time out and get the decimal representation so I can check this. So I don't want the decimal representation, but I just need to check to see what values I get when I plug this in. So I'm talking approximately 2.17, and then the minus one, let's go back up here and then go over and change that plus to a minus and squiggle back negative 9.18. Okay, so I don't need a calculator for this. It's just going to check it. 2 and some change plus 20, that's positive. 2.17, that's positive. 2.17 plus 8. So the positive one is going to work. Okay, but if I put a negative, that negative 9.18 plus 20, that's going to work. But if I put a negative 9.18 in here, that will not work. Okay, so the final answer, I don't want to erase. I'll just write it right here. So the final answer is x equals negative 7 plus square root of 129 over 2. That's your final answer. And I don't want to be unclear. Sometimes students are not super clear on what the final answer is. They make the teacher play multiple guess, and we don't want to do that. So I'm going to erase that. That's my final answer. The minus one didn't work. Okay, so that's the example. What do you do if you have logs on both sides? All right, the last thing that might happen is you might have a log equation that does not have a log in front of this number, and that gives you a little bit of a problem. And I forgot to mention that I solve these a little bit differently than the lab manual might take you through, so just be aware of that. But anyway, what do you do if you have a missing log? Okay, well, what you're going to need to do is still get one log on the left, but then you're going to rewrite it in exponential form, and that's a little tricky for students. You still have to check for extraneous solutions. Okay, so the first step is 2 logs subtracted is 1 log with these values divided. Okay, so that just came from the quotient rule. Alright, now I can't drop the logs because that one doesn't have a log. So what I have to do is I have to rewrite in exponential form. And if you don't practice these enough, I've just seen people draw blank on the test. So remember, if you have log base b of x equals y, you can rewrite that as b to the y equals x. That's log form, that's exponential form. So that's what we have here. We have a base, we have a number, and we have an exponent. So if we want to rewrite this, that's going to be rewritten as 3 to the 2 equals x plus 15 over x minus 1. And now, just like the example a couple of minutes ago, we'll cross multiply. So that's 9 times x minus 1. That's 9x minus 9 equals 1 times x plus 15. So that's going to be 8x when you subtract x from both sides equals, let's add 9 to both sides, 24. And divide by 8. And x is 3. Well, let's check it and see. Remember, you have to check for extraneous solution because this is started out of a log equation. There's a restriction on that. It has to be greater than 0. So if I put 3 there, I get 18. That's fine. If I put 3 there, I get positive 2. That's fine. So that checks out. Alright, let's try this last one. You look at it, it's a log equation, but this is missing a log. So we're going to have to get one log on the left. This time it's 2 logs added, so let's use the product rule. This is the log of x times x minus 3 equals 1. That time we use the product rule. Now I have to, this is where people kind of like, I'm stuck. Just don't see it. And it's really hard because there is a base there that's understood. So it's base 10. Remember, if you don't see it, it's base 10. And we want to get rid of the log, so we can simply rewrite it in exponential form. That would be 10 to the first power equals x times x minus 3. And that's going to be quadratic. So some people might get stuck there. You got to multiply this out, and then you have to set all quadratics equal to 0. And then factor. This one will factor x minus 5, x plus 2. And then set each of those equal to 0 to find the zeros. If you can do that in your head by now, that's great. So you get x is 5 or x is negative 2. Then you have to check your answer. So we'll go back to the original. If you put 5 in here, you get 5. You put 5 in here, you get 2. 5 is going to work. If you put negative 2 in here, that is not going to work. Also not going to work there. It only has to fail in one place. Alright, so that's your only answer there. That's how you solve log equations. Again, go practice in the lab manual. If you go read through the lab manual, they might take you through the steps a little bit differently, but that's how I like to solve log equations.